Greetings, this is Artie from Artifact Electronics. So I guess this is Commodore PET Part 3. I wasn't really, or hadn't really planned on doing this, but if you watched the last two episodes, there was one lingering problem left at the end that I kind of pointed out, but conveniently glossed over. And let me give you a brief reminder of what that problem was. So here's a shot from part 2. And basically the problem was that everything seemed to work, but the screen geometry was off. So I put up this little program that just filled the screen, and if you look at it closely, you can see that the rectangle is not a rectangle on the screen, but rather squished from both top and bottom on the right side. So the left side looks kind of okay, but then if you follow it over to the right, you see that it's off. It's the geometry, like somebody put the right side into a vise. And I looked at it briefly. I couldn't figure out what it was and kind of let it go. But then the other day I was playing with it and I was filling the screen and I wrote a program to display a grid, and it absolutely drove me bananas looking at this squished rectangle. So I decided to spend some more time on this and see if we could fix it. One of our viewers suggested that maybe rotating the convergence rings, or ring, these are actually two rings, but they're on top of each other right now, may fix the geometry. Now briefly, the way convergence ring works is it changes the center point of where the beam would strike the monitor when there was no deflection applied whatsoever, which should be the dead center of the screen. Now on an RGB monitor you have three guns, and what happens is if they're not converged correctly and you look closely at a pixel, a white pixel say, you won't see a white pixel, but rather you'll see R, G, and B pixels slightly offset from each other, usually like in a triangular arrangement or something. And the way you bring those in line is you turn the respective convergence rings till all three pixels coincide exactly. However, in this case, the convergence ring does the same thing, except there's only a single beam in here. So all this does is it changes the center point of your image. So if you turn this thing, your rectangle or whatever is on the screen just happily moves around in a circular fashion. But it does not affect the geometry of the picture at all. So what else could it be? Well, it's some sort of, this thing generates a magnetic field, and if something is off here, if this is not perfectly symmetrical, then it might deflect differently on the left or right side of the screen, or top or bottom of the screen, or both. So what I figured out, if you're looking at this little wheel over here with the pins on it, this had a tiny magnet like this attached to this pin. So what I figured was okay, so they fixed little magnetic discontinuities or changes from one side to the other. They correct it by placing one of these small magnets in one of these pins. That's what they're there for. And so at the factory they put a grid on the screen, and then they play around with these magnets till they got good geometry on it. So I was curious about this, and this thing was inserted here and attached with eternal glue, of course. And after a lot of tooling around with it, I finally got it out. But, and you can't see that, but when I took it out, I basically, this pin is like hanging from a thread. It broke off the pin. So, no big deal. I can just use some other eternal glue to put it back on the stub of the pin. But the interesting part was that removing this magnet caused no change on the screen at all. The distortion in the rectangle was still there, and just manually putting it close to its original position and pulling it away, I mean, I could see some slight changes, but they were very slight, and so this magnet really wasn't doing a whole lot. So I thought about the problem for a while, and I came up with that there's got to be something magnetic in here that's deflecting this side of the screen where the squishing occurs, or maybe this side of the screen where expansion occurs. I don't know, take your pick. But, you know, it can't, the source can't really be the chassis, because, I mean, if they had strong magnetic emanations from the chassis itself, these things would never work. So that must be taken care of, so it must be coming from somewhere else. Then I noticed that this frame over here is made of metal, going all around. Also the bottom of it is metal in here. So, I mean, it's metal, it's not a magnet, but you can magnetize metal. So my theory went like this: what if this sat, it obviously sat somewhere for a really long time, close to a magnetic field, like a speaker or anything else with a permanent magnet in it? What if part of this frame got magnetized and is causing the distortion on the screen? In order to test that theory, I got a magnet that's pretty strong. As a matter of fact, when I put it right next to the yoke, the picture goes bananas. So as far as this tube's concerned, this is a strong magnet. But since my guess was that somewhere in the frame over here, something got magnetized, I had two choices. First of all, I could strip this thing down and then run like a VHS tape eraser or a big electromagnet, something you would use if your DGAUS coil doesn't work, and try to demagnetize this frame. But in my opinion, that was kind of a fool's errand, because I couldn't test it in real time, and I would have to do it, put the thing back together again, turn it on, test it, and that would go on forever. But I think I just said, what if I do that while the set is on? So I did. I'm not going to bring the magnet close to it now, and you'll find out why, but let's assume this is the magnet. So what I started doing was running the magnet around the metal frame like this. And I found a spot just about here, which doesn't even coincide where this magnet was, but it seems to coincide with wherever the magnetic aberration is in this frame. And moving it around and back and forth, I got a good square picture out of it. The geometry was fixed. Hooray, I said, I got it. All I have to do now is tape that magnet here and tape it securely, and my problems are gone. But then, of course, the problem was that the height of the magnet wouldn't have let the case come back in here, and I had to figure out, can I put it underneath? And anyway, there were too many more problems, so I took the magnet off and went and did something else. And when I came back, surprise, surprise. So I typed in my little program, and look at that. The image now is square. So the big surprise, of course, was that, wait a minute, I took away the magnet, how come it fixed the picture is still fixed? So I guess putting the magnet on the metal frame had a twofold effect. Not only did it fix the picture, but it also magnetized and or demagnetized a certain part of the frame. And so the frame, this is not an ideal situation, because I think the frame, if the frame's magnetized, it's causing deflection. But I think what I did was I demagnetized it. And since I demagnetized it, looks like we have a great picture now. I mean, great geometry. It's not centered exactly. It needs to come down a little bit. But I think the problem is fixed. Well, I think that wraps it up. My only worry was if I put the back cover back on, would that affect anything? But this cover is made of plastic, so that's not going to cause any problems. And that's it. Put on the back cover anyway, just to make sure that nothing would change, and nothing did change. Thanks for watching. This is kind of interesting because by total coincidence, I will probably be dealing with another monochrome monitor really soon, but this time it'll have something to do with an arcade game. So make sure to subscribe, and see you next time.